not everybody is back, but I will continue anyhow, just for you. So we've seen Talcop optimization, that it worked, even though a lot of people say that JVM doesn't support it. As you've seen, it doesn't have to at all. By the way, who knows Scala? Okay, this is like, in Scala, it's also well solved in a language that, even though Scala emits the bytecode that is way closer to Java, basically Scala has methods that are compiled to methods in a bytecode. It's not as crazy as here, but still they also support tail recursion, which exactly you put, compiler finds out that it can be changed to loop and it works. So it is not only Eta that does it. Okay, one last thing about JVM. There are tons of things about JVM. I wanted to show you the problems, because those problems, if whenever exactly, by the way, how is your name?
Alex.
Alex. Like Alex is doing very interesting thing. He is comparing, making benchmarks for GHC, Eta, comparing that stuff. And it looks quite cool, but the point, benchmark in JVM is tricky. So best is to use JMH. Otherwise, what you measure is startup of JVM, a lot of crazy stuff. And basically, in JMH, they make a perfect sentence. This is, by the way, valid for every benchmark you do. Numbers are one thing, but benchmark is only valid, only makes sense if you can tell why something is faster or slower. If you find out, okay, Eta generates this code, and this makes it slower, then you found out the reason, and now you can, let's say honestly, oh, then Eta is slower than JC. But to the point where you've seen, as long as you cannot identify it, maybe there is some strange effect. Maybe a code is, maybe then code is just accidentally slower in Eta, but maybe something will be faster, because every compiler has some edge cases. Java, especially Java virtual machines, has some special edge cases that for some codes it's extremely slow, for some codes it's even way faster than static compilers. The second really rarely, but happens. So to answer a question, something is always slower or faster, it's basically always invalid, but for, let's say, to say, for instance, calculation on ints, on arrays or something, it's slower or faster. You need to find out why, and those tools let you do that. Okay, one last thing, which I will not cover much, but you have to know about it, is garbage collectors in JVM. So you know JVM has garbage collector, but do you know how it works? Who knows how to work with garbage?
Just like count references to...
Okay, we count...
More than one, right? You can pick.
Yeah, but counting references. This is a thing I was doing in the past with C++, and works for me, okay? But there's one problem. Let's suppose that you have object A that references object B, this references object C, and this back A. What you have? Cycle, which will be never solved, will be always occupying. And the problem is, in Java, basically, okay, by design, if you do such cycle, it typically means your design is wrong, but it's allowed. At least in Java, it says Java allows it, and it should garbage collect that as long as no one else is looking at those objects. If they are just alone keeping themselves together, even two objects, A holds B, B holds A, and now no one else knows about them, then they should be reclaimed by garbage collector. So how can you do that differently? And do you know the second problem with reference counting? What's also the problem with the reference counting apart from cycles? It's also not very performant. Because if you share object intensively, like you pass it to different methods and to different objects, then you constantly are changing this counter. It might be really visible. Yeah, so that's the second thing. Although it's, I would say, still not as bad. So what's the other option? You have objects. Let's forget about Eta. You have a machine, basically has objects. Objects, it's like a graph. Objects. And there is always something like a root object. The thing, actually there are more of them, but those are objects that you have in code. Like in your code, you have like variable, let's call it variable, which references some object. And this object, other objects, blah, 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 blah. And there were some objects in the heap that no one is referencing right now. So from the root objects, you cannot get to them. How to do the garbage collector? Who knows how? Because basically, there is a method to do that.
I mean, do you just walk the tree and mark everything that you can see and then throw away stuff that you didn't visit?
Yeah, that's the point. So basically, machine knows all the objects, all of them. This is JVM, so it knows everything that's happening. On the other hand, it knows those roots. Typically, there are more like a couple of them, like even hundreds. But then starting from those roots, it basically marks all the visible objects. And after it marks, it just said, oh, let's go through all the objects and see who was not marked. That's basically marking collector. And then it removes them. What's the problem with that? Okay, the problem with that, if you think about, I have 2 gigabytes of heap, 100,000 of small objects. This takes some time, and there is a bigger problem. This garbage collector works, and what can in that moment do application if the garbage collector is working through this side, to this graph?
It's changing, the tree is changing as it's measuring.
Yeah, so the point is, sorry?
Unless you freeze the program.
Which exactly some garbage collectors do. So basically the basic garbage collectors for years were just doing, let's stop the world, go all the graph, and then remove those. Okay, actually removing objects after you marked out of them, removing can be done parallel with application. But marking, no, you don't want a graph be changed, because then actually it's easy to show that then you can miss objects, you can reclaim objects that actually are used because the reference can be changed. So basically that is one of the biggest issue with this, that with a garbage collector, you have from time to time stop the application. And this is, yeah, if your heap is big, this is visible. These applications like those windows, yeah, user is clicking on a button. That's a really horrible experience when you click on the button and nothing happens for 2 seconds, yeah? And the bigger heap is, the more visible. So, but what you described is mark and sweep, basically. You mark and sweep things you don't want. That's simplification, but. And to solve that, and I won't go to the details, but there are a lot of interesting talks. This problem actually was solved only recently. So serial and parallel garbage collectors, those are the basic ones in Oracle JVM, they basically do a lot of stop the world. So basically, not full time is stop, they do garbage collecting, but they stop. Then they have concurrent mark and sweep, which basically means that one of those phases, marking, is partially concurrent. There is still stop the world, and I won't cover the details, but for instance, more or less going down this, with some exceptions, you have smaller pauses and smaller stop the words. So G1GC is very interesting garbage collector. Again, it's not today the time, this is not a talk about the garbage collector, but it is for huge heaps, really like gigabytes, to reduce the pauses really to milliseconds, really. Almost not visible. And almost the same, there's like Shenandoah and ZGC, they are like even a step farther to G1GC. It doesn't, and the problem is we have now plenty of them. ZGC is not in Oracle, in fact. No, it is in Oracle, but it's based, okay, it is in Oracle, sorry, I forgot. And the most fun, you know, Epsilon GC, this is the newest. This is the best garbage collector you can imagine. You know what it does? Nothing. Never. This is actually the garbage collector people are using while doing benchmarks or low latency code in Java. So this garbage collector totally removes garbage collecting. It's just disabled. So it is a lot because, for instance, when you do high frequency trading, people do that in Java. And The problem is you don't want any pauses. How people write programs, they in Java, for instance, pre-allocate all the objects, and they are only constantly using the same object, and they do worry to not allocate anything. It's very hard to write programs like that, but it's possible in Java. The problem is, with all those garbage collectors, even if you don't allocate anything, they will still be checking that. And we'll be doing small pauses. You don't want to do that. So finally, it's only recently, well, that was actually quite a huge commit. They created the epsilon GC, which basically you eliminate any garbage collector. It means this is absolutely no code active. Even it means even that objects have some special, each object has a special field, this for marking. Am I alive? Not. This even is removed. It means you can actually put more things on a heap because it's now objects occupy less. I've heard so, I haven't checked this one, but that was the goal. And if you do benchmarking for CPU, actually it might be sensible sometimes to think maybe it can be done with epsilon. Especially epsilon makes your measurements more stable because you don't have random garbage collector, because garbage collector is just process that randomly, in some random moments, checks if there is a garbage. You cannot control that. Epsilon makes it like, no one checks anyhow, never. But basically, if you do batch processing, if you are doing servers, typical servers, typically you mostly go to G1, GC. It depends. Okay, actually depends on your problem, but you can actually afford yourself pauses because networks, although anyhow slower. If you do client programming, which is very rare with JavaFX, nowadays almost no one does it. Then you think about reducing pauses, but I would say CMS and G1, GC are interesting for that. And the last ones are, I would say, rather for this high-frequency trading or some things where you have really huge processing and huge heaps and things like that. But I say the problem is, few times I was able to fix performance of not only the pauses, but also performance of the application, changing something about garbage collector, but it's basically no science. You just change some, all of them have some parameters, you change them. It's like optimization process. You change some parameters and you see, is it better or worse? You have to measure. This is like really, and I would say like 90% my intuition is wrong about if I want to make shorter pauses, then I choose some, let's say, better garbage collector, and I end up with bigger ones. This is really, and of course the point is that the ones that stop the world, actually, when it comes to true output, they are the fastest, because those that are very concurrent and run with your application and do reduce the pauses, they have a lot of more things to do to be sure that there is no like. How it's called, that there is no leaks of references. There's like a lot of more things to be done. So that's a trade-off. Basically, it's like this. So, but this is like, you just have to read and you have to check. It basically, I tell you, I am 20 years with Java, and most of the time when I am tuning garbage collector, I still have wrong intuitions. I just check. So typical check is you start the program for 2 minutes, which does exactly some given steps, and you check how much time was spent in the garbage collector, or how much processing you did, or how long were the pauses. You just depends on your goal. You have to make a test and measure. You can measure that, let's say, in a normal way. Just I will go to, if you have just a project, I will go back to exercise 2. Yeah, again, beautiful. Oh my God, please be faster. Beautiful game of life. Okay, then I can do something like that. There is in each JDK, actually, at least from Oracle, there is a thing called JConsole, which doesn't have perfect GUI, you see, while we love Java, but it's actually a useful tool. So for instance, you go there and you have statistics. Actually, quite honestly, some of those windows are the same you've seen before with with Visual VM. Like this is CPU usage of the application, but this is like a heap totally used. But here is like heap usage, and just a moment. Yeah, this is very interesting. For instance, you see that concurrent mark and sweep was used. That's actually the face. And now the question how interpret these things, you have to read about it. I won't spend time on that, but there is something like young generation, old generation object. You know this concept? Young and generation. So basically that most of the objects are created for short time. So basically there is a special list of objects that were recently created, and first they are, let's say, checked if they are dead or not. And if some objects are, let's say, long time, then we don't check them that often. But okay, and now we can see that, for instance, this application already totally spent so much time on garbage collector, which is actually a lot. But okay, this is the point to analyze what. But this is, I would say, a typical problem. And in case of Eta and a project, this is very visible because Eta compiling to these small class methods, etc., creates, and to closures, you will see that creates a lot of small objects, like incredible amount, and a lot of them are not really detected by escape analysis, and then garbage collector really has a problem with that. But hopefully it will get better. Maybe I can show you that. Let's see. Let's say it's not yet there, but it's close to be better. Now, why? Because that's actually something people from Oracle, just a moment, for last couple of years are really seeing that people do more and more functional programming. And they do this functional programming in Java, in Scala. Okay, Eta is, they know about Eta. I don't think they consider it like main goal, but closure is, for instance, already visible. And they see that, okay, we want to make this JVM behaving better. And they already invested a lot of time and in making JVM more friendly to functional style, even in Java, because in Java as well, you write functional style in Java, you see that Java is not really well for that. You create a lot of temporary objects, but still it's more secure way of writing code, so people do that, and now Oracle is trying to fix this in JVM to make it better. So they created this. Have any one of you heard about it? This is a cool stuff. I really like it. So, JVM is written in which language? Who knows? The Oracle. Okay, it's basically C++. Like the virtual machine compiler. And it was written in late 90s. Fixing and tuning anything there right now is a horrible thing, because this code is, tons of people were changing those things there, and even to add a small thing is a problem. It's not really the worst code I've seen, but...
I think compiler was redone for 1.3 by others. So we knew it, like 2002. That's my understanding.
No, I'm talking about Hotspot. And Hotspot was introduced with version 1.2 to Java, and this code, that was, I don't know, 99, something like that. And this code really still, they did a lot of things. They refactored it a little bit, but they say it's not really maintainable. And they have a lot of ideas how to make it better, but the code became hard to change. So someone had an idea. What? Because what this code in C++ does, I'm talking about C1 and C2 compilers, so to native code. They basically analyze running code and generate assembly code somewhere. This doesn't have to be done. This can be done with any language, and they decided, why we don't do that? Why don't we do that with Java? And the Growl project is basically that in JVM, there is a Java, really Java, that generates this assembly code. So basically, as far as I remember, this is C2. So this most aggressive compiler, optimized compiler, is actually now, you can replace it with Growl. So I will show you that. For that, I have to use the newest version of JDK. It will take me a little bit of time, but I will show you something funny, which I really like about it. Because some of you may already see one funny problem. Guess, what is interesting if you do this? Like, inside of the JVM, you have a Java process that analyzes your code and creates assembly out of that. Actually, yes, you are right. This is one of the problems. But this is a minor problem. Okay, I don't even say there is like a problem. There is like interesting thing happening.
This is operating on itself.
Yes, that's really. So I will turn print compilation. I have to, because this is Java 12, I have to make my life easier, I have to enable this part. Yep. Okay. And it should be that. Okay. I will, yeah, that must be. Oh, I made a mistake. Oh, okay. Okay, so what's my problem here? G1GC, where is this? As 90 column. Yeah, yes, you're right, thank you. IntelliJ, thank you. IntelliJ doesn't let me put comma right behind it. This is really awesome. Which makes no sense, but okay, this is a feature, not a bug. Oh, again. But what's the next problem? Compile Java. Ah, maybe. Okay. Not that easy. I think like that. Oh. What? Ah, this wasn't bit faked. So it's running, compiling. Yeah. So I have it right now. Now it's really slow, actually. It's not fast for a moment. But if you look at this print compilation code, you see these lines. This is really cool. So compiler, especially at the beginning of that, now when you start, this is the start of JVM. You only see Graal VM. It means JVM is starting itself, and at the beginning it starts to compile in its own compiler with itself. So Graal VM is compiling itself to assembly. This is awesome. By the way, you can disable it, which means your compilation will be slower, but your application will start a little bit faster. Okay, depends what you need. But this is this. And I did some measurements. Is it faster or not? And basically, it shows that at least for ETA code, at this moment, and my small, let's say, not really professional benchmarks, the difference is negligible. It's like almost no difference. It's not worse, not best, doesn't make any sense. That, for instance, Twitter is using Scala massively, and they have a huge, one engineer from Twitter is saying how much money they saved by introducing Graal VM, because now they need less machines, because the same code runs with less CPU. Exactly. So it's already like money, because they have thousands of machines. So if, by the way, the difference in their case was like, I don't know, 1.5%, but it already for them was something visible in terms of money. Interesting. So, so this Graal, actually, I would say this is one of the huge things that is happening right now in JVM. And because this is a new code, this is massively, a lot of optimizations right now are written to that were not easy to be implemented in old C code. And what they already claim to be doing better is this escape analysis. And this is exactly visible in Scala code. Unfortunately, for some reasons, maybe we have to analyze why, I don't see this gain in ETA code. Maybe Graal should be better. Maybe there has to be some changes done in ETA so that it will be more friendly to the optimizer. But this is a huge thing, because we expect that now the performance, let's say, maybe it will be not skyrocketing, but now the JVM will be made faster with which we release constantly. It's actually, for a lot of benchmarks, it's visible. So because this is now more people can analyze this code and implement their crazy ideas. Okay, so that was it. And it's good to know about it because exactly that's the goal, is to make the functional languages more performant. Okay, so we go to the part 3, into the ETA. This part will be a little bit hard because I don't expect that you can follow exactly, but this part I will be trying to do something in one moment, but I just need your help, more possibly. The problem is we'll be digging into ETA code. This is a compiler. This is a huge one, and even downloading it, the sources, doesn't take that much time, but compiling it, if you don't, even on a decent machine, it can take like 20 minutes. So yeah, we don't have this time. So depends, of course, what you do, but I will try to show you what I can, and we'll see. I don't want you to waste time on watching things, compiling, etc. Okay, so optionally, but I will show this link. We have, if you are interested, ETA code is open source. Okay, GitHub. So you can simply fork it, and it's really fun. Person, you see the project, blah blah blah. By the way, that's my name. I'm officially contributor. I did really few stupid things, but nevertheless, they are really they are happy to put someone there. Let's say I can tell you that I don't know all these people, but this one is a very, let's say, active developer. And okay, actually the main is Raul Muteni. He is not, okay, this one. He is the main committer, basically, from type lead, and he does all the stuff. He answers the questions, and by the way, and he helps. So the point is, now you won't believe that, but I think that was, I'm not sure, that was 2 years ago, that was a year ago. I was a Haskell developer with possibilities to write Fibonacci. That was me, and Hello World, of course. I knew Haskell for years, but I was never, let's say, I was only doing some, small plays with Haskell, really. So I never learned IO monad well and things like that. And then I decided to present ETA because it, for me, was interesting. I like these languages. I basically found out that I can't go further without pure language, and I wanted to check ETA. And then I started to do some stuff. I started to check if TCA works. It didn't. Then I analyzed the bytecode, and that's the funny story. And I found out there is an error in bytecode. And then I was going through the Haskell code and realized, oh my God, that's the first time in my life I see like thousands of lines in Haskell. I can somehow read it. Actually, it's quite readable, even if I don't know the language that much. And I found the places in Haskell code which were responsible for this more or less wrongly generated bytecode, because I knew bytecode, so I knew what to look for. And then I posted where is an error, expecting that Raul will fix that, because it seemed to be trivial. But the guy basically pushed me to fix on my own. I can only tell you that my first, I have some commits which I shouldn't show to anyone, because this is probably one of the ugliest Haskell code you've seen. But then, and by fixing the first error, I created 2 other ones, but then I fixed it, and finally it was polished, and maybe it's now better. But it was like, I'm not sure, 2 years ago or a year ago, I don't remember. But so they are really encouraging people, and the Raul was really helping me to, he wasn't punishing me for writing crappy code. He said he will fix it later, but he was really encouraging. And that's really, I see he does it exactly with other people. So that's really one of the projects which I would say it's friendly for contributors, really. And it's, I was surprised how easy it is to make something that fixes or brings something new. Okay. So that's for you. That's why I'm still interesting, because if I'm doing some Haskell for fun, why don't I do something which really makes someone happy? This is one of those projects where you can really deliver something, and really, you don't have to be even good Haskell developer. You can learn while doing, really. I am 40 years old. I could learn that, so you can do it much faster. Yeah. Okay, but let's go And by the way, but still, I'm in terms of Haskell and that stuff, I consider myself junior. So I'm telling you the things I learned, watched on videos, and I've seen that in code of ETA, but I don't call myself even let's say, very experienced. This is like things I touched, and I know where to find, but so Haskell compiler, no, the problem is, maybe we do that like this. Haskell compiler has some phases. And this, as far as I know, this picture is actually not really true, but nevertheless. So of course, it has to parse some file. Then it does some renaming. We don't bother about this. Let's say for human named things, it assigns some other names, but I don't really know this phase. Then it does type checking. You know what the type checking is? Okay, that's the thing we need from typed language that basically finds if the types match, so the code is, let's say, valid. And then there is an interesting phase called the sugar. Who knows what this is? The sugar, yeah.
It's taking stuff like a do notation and converting it down into all the parens and bind operations.
So yes, so Haskell has a lot of syntax sugar. So things you could write quicker, but there is a like longer, let's say, original way of writing this. And this is the sugaring, means basically we strip all this syntax sugar, we make the code, let's say, longer and even looking nasty, but so that later phases have, let's say, simpler syntax tree to play with. So this is easier to do them. More or less like that. And then there is something called core. What is a core? Core is a smaller language than Haskell. It's a functional language. And I'm not really experienced with core. I haven't even seen. I think I haven't seen the syntax even of core. But this is like internal language that during the compilation, Haskell is compiled to this language. This is like simplified Haskell, let's say. It's really, and this simplification works in some phases. As far as I know, this is not on this picture. Actually, type checking happens more often here. I think after each simplification, I cannot tell you for sure. It's not on the official picture, but I've heard it a few times and I read it somewhere already. So I think this picture is not really proper. But nevertheless, there is like Haskell is converted to some simpler language. This is one step, but this is not even the end. Okay, I will skip because this is all core. Finally, core is converted to something which is called STG. And there is not that STG is again simply and now extremely simple language. Who knows lambda calculus? Yeah. So can you describe what lambda calculus is? Okay. I have one sentence for that. Okay. Try. Maybe you have better.
It's a programming language invented by a guy named Alonzo Church in 1920.
Wasn't it like 30? Okay, I don't know exactly. Okay.
And it basically has this two main abstractions of application and abstracting out the concept of the name, or a function without a name. Basically, think of it as a function without a name, which has variables, and the variables can be,
Okay.
Good.
You have some better definition or a different?
I would say lambda calculus lets you describe function abstraction
Okay. Okay, so actually you did the definition of lambda calculus, but so we have basically nothing there. We only have world when we have like our atoms are functions, and we have possibility to create functions, so describe them, how they are, and we can applicate function. And by the way, it means when we describe function, what this function is, inside of this definition, we can only use function application and maybe create another functions, which is cool. So that's like our language. For that, I call it like minimal, let's say, minimal functional language. That's like, I cannot imagine a smaller one. Like, this is like, have you ever heard about minimal assembly language? How many machine codes you need to have a Turing complete machine? How many assembly codes you need to have a... If you are designing a CPU and someone said you only can have one opcode or two opcodes or three opcodes, how many you need of them to create?
I think I heard them describe it was two. It was like try to add some new register if it's full and then jump or something. It was really simple.
Okay, so I can tell you even on Intel. Okay, the point is CPU is one thing, but looking at the whole, let's say, architecture of Intel, having BIOS and some machinery behind, you need exactly one machine instruction to have Turing completeness, which, by the way, is move instruction. If you look for like single, there is something called single instruction assembler. I've forgotten the official name. There is a better instruction for that, only one. But let's say with a trick, with machinery, it's possible, and it's proven that move is enough for Intel. for let's say for Intel on PC, okay? Because they use some trick to, let's say, restart program. Otherwise, it would be hard. Basically, there's like you need to jump. But basically, instruction like I think the minimal instruction, and you don't need anything more, is like subtract, compare, and jump. If not, like one instruction that if it does these three things, then you can do everything. So you need the one instruction. So lambda calculus is like something corresponding in a functional, like this single instruction CPU is like imperative way of doing stuff, and corresponding thing dual, let's say, in functional world is lambda calculus, because I cannot imagine less. Maybe there is, I don't know. Maybe it's proven. And lambda calculus is Turing equivalent, so Turing complete. You can do anything which is possible with. This means, by the way, if some of your colleagues says that something cannot be done functionally, he's wrong. It's proven by Turing, actually, that lambda calculus fully functional, there can be nothing more functional than lambda calculus is Turing complete, Turing equivalent to. Yeah, so that's the thing. So STG is, it's not lambda calculus, it's more than that, but it's this. By the way, I love lambda calculus because it allows to create alternative definition of everything we know from mathematics. Like in lambda calculus, we can represent natural numbers, subtraction, plus also like there is a function that in lambda calculus that represents number 3. That's a function. There is a function that represents false. That's a function. And there is a function that represents end. And you have only functions for everything you can imagine. There is a function that represents list. There is a function that represents if. There is a function that represents all the recursion. There's a function that takes a function and makes recursion of that. Actually, fixed point operator, which is really cool. But nevertheless, this is a cool language. But STG, it's, let's say, lambda calculus made realistic, because writing in lambda calculus is like writing in a brainfuck. Who used brainfuck? Who's seen brainfuck? It's possible, but you only do that for fun, not for real. STG, okay, STG is not really very practical, but at least it's something you can read and it makes sense. So this is like Haskell at the end, after many steps, it's converted to something called STG. And then what's happened? From this STG, GHC is creating like, actually right now, those two things are machine code or LLVM code. So basically, STG is also kind of like machine, because everything is described there, and now we know how to translate to machine code. or to LLVM, which is as well almost like machine code, and in the past it was to C code. In terms of ETA, very important, everything up to this place STG is basically forked from GHC. The difference is like foreign function interface. So the places where in original code we are calling C are here adapted to use Java, but it's really small changes. It is the same code. It means to the STG, it's fully complete. And by the way, almost everything happens there. So that's why ETA supports all these compiler extensions, all the things that GHC supports. And only then on the last step, actually, we have in ETA other possibility, generate bytecode. Yeah. So, of course, the question is why is not something like ETA a part of actually GHC, where we just have additional backend? It would be harder, but okay, it's just not done like this. But also, Typelit, I think, needs to make money. Okay. So STG is a thing that you can see, and you can read about it, and there are talks about it, and this looks more or less like that. I think this is a Fibonacci naive version, and I don't say it's very readable. It's like if you, okay, maybe I will show it. Why don't we generate STG? So where was Fib, maybe exercise TCO. So I could use ETA. Okay, now that won't be all. I have it. I should have dumped into code. This is STG from actually optimized, so from tile recursive version. So we actually see the function fib-tico inner with some suffix. It's probably from this renaming part. Then we see this is like a function in Haskell. You have types. Then you have formal parameters. I don't really read everything. Then you have internally defined functions. Does anyone know of you read STG? I would say this is a rare. No, basically, in STG, you go to STG mostly when you are involved in Haskell compiler. You want to add something. For instance, you add syntax sugar. Then you check at the end if, for instance, STG looks as expected. Like, for instance, you have an original code and you add some syntax sugar, and you expect that after your syntax sugar, it will be working exactly like the previous, let's say, longer version. So this is more or less how you can use it. In terms of ETA, we have additional here thing, which is basically mapping of how symbols from STG are mapped to JVM, etc. So this lets me a little bit better to navigate. Still, it's not perfect. So because those names are sometimes so changed that I cannot find where do they come from original Haskell. But nevertheless, it's like this. And this language exactly supports tile core recursion. And it's like, yeah, it's very minimal. You can read the official syntax. I don't know if anyone in the world actually writes directly in STG, but it's possible. Okay. So that was it. So now the point that you've probably have seen. So if we go to this exercise with Fibonacci, we can see some code like this, maybe this, that. Everyone in the code, you see something like the closure. So extends CAF, extends func, extends closure. This is like abstract class, which is inside of runtime of ETA. So ETA, this is just a moment, run fibojar. It has my classes, like this one. These are like Tico inner. You see, this is the code I've written. And then this is base, ETA, blah, blah, blah. It's all like a runtime, which is added by ETA. So some internal structures that are needed to make it working. So what is a closure? Who thinks what is who knows what is a closure? Yeah, basically yes. So yeah. So everything. By the way, actually at the end, everything that lives inside your runtime is closure. Basically, you will see that. So whatever definition you have here, like let's see what is a set2. It's updatable func. What is an updatable func? 3. It's updatable func. What is updatable func? It's a func. What is a func? It's a closure. Yeah? And closure has something like evaluate, I think probably the most important. By the way, this is abstract class. So it says here runtime bar, like it will only fail, but how to say that? This is abstract. Who knows what the abstract class is? You know. So that's, let's say, it defines which methods we have, but they will be implemented with some concrete implementations. So this actually always fails with everything. Apply means this is a function and we apply with it with a double value, having some context. Okay? I was analyzing it a few times, but I cannot tell you much about it. It's just there. And if you read about Haskell internals, you will see similar structures. Okay, so I mean about GHC or other implementations. But there is one more thing about the func. We've already seen. What is a func? Who knows this? Okay? Yeah, delayed. So why do we have delayed computation at all? So Haskell is lazy. You know, what does it mean it's lazy?
It only evaluates the code as much as it needs to.
Yeah, so if we have function with two arguments like a and b, argument a will be only resolved, evaluated in the moment it's needed. And it even means that if we pass it to some other function, we still don't resolve it. It just pass it, until finally someone really needs a value from this a. This is like extremely laziness we have in Haskell, which already is a, let's say, problem for runtime in Haskell. This is not easy to work with, but laziness is a cool thing sometimes for developers. I love it, even though I understand people have a problem with that. Yeah, but this makes the thing a little bit more complex because we have, for instance, integer. In Java and JVM, we would have integer. In Eta and in Haskell, even in Haskell, we have a tank that might generate this integer finally. But if it's one small integer, we actually have really huge class with some internal structures. Like this is a func. Actually, the update table func. This is the. Okay, we have so many. Where is this? Blah blah blah. This is not the best func I wanted to see, but nevertheless, it means we have in places where we in normal code would see some simple integer or something, we have this kind of structure. And the update table func is again an abstract class, which is then. Okay, and now IntelliJ cannot find it. Okay, finds, yeah, which is then, for instance, this is update table func, which has some int inside, so probably it means this is a lazy int, which will be evaluated, and then we have this function, tank enter, which does some evaluation. What could that be? That's interesting. If I can understand from this code what it does. It takes integer from inside, adds 1 to that, and then makes some Boolean return. Okay, I don't only know this one. I think it was 0 actually, but I'm not. No, that is a false because this is a common symbol. Nevertheless, it's if you look even at this, normally you would have some variable which is int or something. It would be easy to track, but now we have like layers of laziness, and it's even hard to debug that. But original Haskell also works this way, so it's like we don't have it better in Eta. It's just now I would say thanks to that it's in Java. I would say it's even easier to read during the runtime. Okay, so basically what what I wanted you to show is that we have this runtime, and closure and tank are the most important stuff that you see if you do some debugging. But it's easy. Updatable func is some lazy value. Now it's the problem which one of those values that you have is that, but it's possible to find out. I wish there was a faster method, but I don't know. Faster than just analyzing the code and guessing, that must be this. And then we can generate STG. And now I will show you the real problem. Let me go to the close other tabs. So suppose that I have downloaded ETA. You can download as well, but I will tell you this is like a bigger thing. So I will go to Eta-lang org. I will go to GitHub. And there are issues. And one of those issues was like that. That's actually the question. Someone was trying to implement Java interface. So in ETA as well, if you have Java interface, you can implement that with Haskell. Like implementation is in Haskell. There is a way to do that. Actually, it's even shown here. So someone says this is a htest. Let's say this is like a class in Java written. And now we export a function that takes an int and returns Java. So Java monas is like IO. And maybe htest. So what means it returns object or returns nothing. And someone said, it would be great, because Java is written this way. In case of nothing, it would return null to Java. I don't say it's good, but I see that actually it's needed, because a lot of Java system expect that you will return null sometimes. It's horrible, but they expect that. So, and at this moment, there was actually no possibility. I see that even authors like this didn't know that. They were trying, but all those things were not really working. So someone has even decompiled it, and there was like so this maybe htest, this way of writing was expected to deliver null sometimes, but it wasn't working. The null wasn't there. And more, like, read this story. There was even this error constantly that just cannot be cast to nothing. This was really crazy. Why even this cast? Then, okay, I've seen that. And what was I tried to analyze what is happening. And I realized that for some reason, it's this cast that we have, it generates some unfortunate, unneeded class cast to completely wrong class. And I will show you the code right now. So first thing is I've seen class cast exception. Okay, there is a class cast exception. So we'll go back to the code that is responsible for the problem. And now the problem is that I will already show you the fixed solution, but we'll work with that. So, I forgot about one more thing, but I will show you. So we have this, oh my God, maybe problem. We have this code, which basically, this is actually taken from original author. We have htest mk_htest, object get class, and I expect here I will get an object, here I expect I will get a null. So, so now I will do recompile. Oh, this is wrong place. Exercise null. Again. Takes some time. It actually would work, but we'll see why, and hopefully it would work. So as you see, I'm using dumps STG and dump CG, trace and dump to file, couple of stuff. Okay, now.
Quick question. It's not relevant to it, but it looks like somebody's trying to have ability to run inside Java unit test environment. Is it what the actually it's happening? Is the library which allows you to run HPEG somehow inside Java Java JUnit type of thing?
I don't.
That's what it seems like. What this is happening, right? Somebody says to you.
Okay, I haven't seen that because I don't have HSpec is.
HPEG is a Haskell. BDD.
Okay, BDD. Okay, I only.
And this guy is trying to run it, right? You're trying to run it.
Okay, I'm not this guy. I don't know what was his goal. Maybe okay. I haven't used this. I haven't used this H. Maybe that's the thing. I don't know.
Being able to just include your HPEG Haskell
Let's-
code and run it as part of the bigger suite
Mhm.
that you may have.
Okay, I don't know this. Maybe that's the point. Okay, so I wanted to run the Java.
Sorry about the interruption.
No, that's cool. I didn't know because I don't know the whole. Now I will just run jar run null. Oh, I think I did something completely wrong. Why it's hello Eta? Okay. Because it ran Java, but it didn't. Okay, I know what's the problem. I have to run. Maybe I have to gradle vo run. Oh, I did something wrong. Maybe I will. Okay. Nevertheless, so we have this problem, and the question is how can you find out that there is a bug? So actually, I don't have any scientific method, but I went to the bytecode opcodes. Okay, maybe I do it differently. Let me check this one. H-test, and this was one of those. So, what I did here, myres, okay, here. So I decided to decompile a class, and in this class, and that's even this one, I found that there is like check cast done. So someone is doing casting, and I know from the story that this casting was wrong. And I was analyzing, this 47? Now I don't know why I don't see the symbol. Okay, I didn't put all the symbols, so just a moment. I know what to do. Recompile. I will do -v, I bet. But I will do that from. So using this Java P tool, you can from class, see for instance, this is something called constant pool. So if I am doing in a method check cast 47, then I go to 47 and I see that it's casting to class which is 48. And it means it's casting to just. Oh, I just found that someone is casting something to just. The question, is it correct cast? Okay, I can tell you in this code it's a correct one, but in the original one, when I found out, it was wrong. So there was like, this was a wrong call, so here, and it was really visible. This is not a rocket science. It was visible that someone is doing invoke special. Invoke special is basically creating constructor. So for instance, that was like, maybe, okay, get static, maybe this one. Get static, nothing means I get a static value of nothing, because nothing is only one in the system. So this is a static value, one instance of nothing in the system. Using Java, I take get static nothing, and then I cast it. And there was a wrong cast to just. So of course, nothing is not just. And there was a cast exception. So the question is, how can you find where it's wrong? So the best method ever. Okay, probably I'm lying a little bit, but let me grab. Moment, how is the opcode code? Check cast. Cast -r. Actually, I have it in the IntelliJ, but I think this method worked. Oh, I found that there is JVM definition for opcodes SRC codec. So we see that we have something called codec JVM. This is a utility project to lets you, actually this is also would be useful as external library. So you can, if you just have some Haskell which needs to generate Java code, you can reuse this codec JVM. And it has definition of, in code, a moment, this awesome code of checkcast, okay? Oh, moment, where is that? Checkcast. And luckily, you see there are not so many these checkcasts. So here in opcodes, actually those are only defined, that I know what opcode is, and here is the checkcast defined. And there is only one place where it's used, here. Like checkcast, iClass, why do I have, okay, nevertheless. So I was looking at this and realized that it's, okay, what is this? This is something called JConf. I don't know what is a JConf, but it takes a field type and generates code. Code is a, let's say, list of opcodes from bytecode. It's more complex, but let's say this one. And even has this operator. It means it's like join for list is 2 pluses in Haskell. So this means join these 2 codes together and create a bigger code. And it's, so I see this is something like conversion. We do conversion from one field type to another field type, okay? And I was analyzing what can that be. You know what I did? For all these places with checkcast, I did this. Oh, that was the most awesome part I could do. Nope. I added my own instruction, do no operation, which means put nope, no operation there. Let's see. Actually, because if I add it, do we have it? I'm not sure. Maybe it's already removed by me. Maybe this code is already... Okay, nope is not there. But I was basically checking if I have nope. I can tell you simply that I just compile it with other version. I don't have time. But that was one of the ways of doing that. Other ways was doing that very simple, like putting, let's say, here, instead of that, error. Something, compiling and seeing if I'm in the correct place. Error, and then you put blah, blah, this. I'm here, whatever. And checking if this, if I go there. This is the problem. Compiling of Eta and then compiling your code takes a lot of time. As I said, 20 minutes. I actually only recently discussed how to make it faster. They told me something, but I haven't yet checked it. This is slow. But because I found this, where this code is used, that's why even I put this no operation there. So I checked, oh, now I have nope, oh, nope bytecode close to the place, so I know this is the place. So now, how to solve that? I didn't know a good solution for that. I hoped that Raul will tell me. But it appeared that the solution would be, let's treat, oh, I can show you. But by the way, as you see, in this moment, you don't really have to know Haskell that much. It's just you do search, okay, JConf. Maybe I will be able to find it. I don't say it's really fast. It's a little bit slow work, but honest. And you just go, where is JConf used? Okay. I can tell you I found this place. Actually, and I can even tell this wasn't there. So I found that this problem comes from this conversion. So what is this? Like, oh, again, JConf. So this method is called unboxResult. And I realized, looking a little bit at code, that every time we return from Java generated, by the way, this is DS foreign. It's shown me that probably this is the correct place. So I mean, this is a foreign function definition. So every time I'm returning from foreign function, it is the JConf is done. And what you see, it generates return statement with cast, basically. And that was kind of, normally it works for every type, but for maybe it was just not working correctly. And I knew that actually we simply need this definition that we need to have null or the original object if someone uses this maybe. So the solution was to add additional guard. And I could only do that because I found there was additional is bool. So they have already did a special case for Boolean. If someone returns Boolean from Haskell, they return this special code from Java. And I can simply tell you this is like converting Haskell Boolean to Java. There is nothing special in that, but it's fun. Okay, whatever. So it means I can check if maybe this is maybe. I created the if the type I'm returning is maybe, and create the special version for maybe, unbox maybe. Okay. So this is the special version of unbox name maybe. Again, not that big code. And what we do there? The point is, we have some object. This object is on top of stack. We want to do a simple thing. Check if it's nothing. If this is the same as nothing, then I will return null. But otherwise, I will exactly do the previous code from this otherwise, this thing. Because this would be a correct solution. So only if it's nothing, then do something else. So how to do that in terms of a bytecode? I can show you in the bytecode how to do that stuff. So first of all, so you have some variable like a. This is maybe nothing or just something. And then what you can do, let's start from this place. This is where, let's say, original code ended. Now we do a change. We take a nothing instance and put it on the stack. So we generate this getStatic. And actually, you've seen this getStatic. And here I find I even by name find the instance of nothing. I found this code somewhere else in the in the Eta compiler. That's how they refer to known objects, let's say. So we do getStatic. So now we have object A, the interesting one, on stack. And on top of that, reference to nothing. What we then do, we generate comparison. This is compare to references. This is a valid opcode. Maybe it would be great to show bytecode instructions. I was looking at this and there was like if CMP. If references are equal, branch to instruction at branch offset, otherwise you will just state. So this kind of if. Okay, this is this if Q. Okay. Of course, some of you may see the problem. So we have two values on stack. We take them, and just branch somewhere if they are equal. So if so, then we do. Okay, if they are equal, actually we jump to 46 because it means we had a nothing instance. So what we then do? This is a bytecode instruction, and let's see in ETA. This is the line I've written: a const null, blah blah blah, and then greturn this. This basically means that I construct this null and then I return this to the field res_ft. It's like a little bit. I couldn't write this code like that. I didn't know what to write, but I was looking what kind of errors ETA is generating me. Luckily, this is a type-safe language, so from type, I knew which type I need. Then I was basically looking where is the function that basically has those types, and I knew what to do. It's like I really didn't use any special Haskell knowledge. That was like try and error, but with compiler guiding me. So cool. Because of that, I love Haskell. So I knew that return null. Otherwise, and this is basically now copy-paste, with this if ACMP, we basically provide two parameters. One, what if yes, one, what if no. And that was code. It doesn't even fit to line. That I have to still to fix that. That was the code stolen from here. So that's more or less this JConf. But after some changes, I don't know why I had to do some more play here, but there was a reason for that. But I basically seen what it does and converted it to this. Okay. And after that, we have this code, and it actually works right now. The question is, why is this dub here, and why I had to add it? Who knows? Yeah? Yeah, that was a funny thing. So if you do if, that's basically all the opcodes from bytecode, and this is actually well documented. That's why you have this. So if destroys, so after I did this if, the original object A wasn't there anymore on the stack. So in order to fix that, first you have to do dap, duplication, then you can do this if, and after this if you result, oh, again I have A on the stack. This is cool. And by the way, this is ugly code with a lot of copy paste, but it already solves the problem. Which is, the problem is already a little bit crazy, who would need null, but yeah, Java needs that. So yeah, well, that's basically this, yeah. The question is, okay, and I think I'm at the end of my.
Did you show again this original ticket that had this code?
Of course, yes. Yeah, by the way, this is the point, maybe. I already seen that at least 2 of you are way better Haskell developers as I am, so maybe you have other ideas. First one?
The problem, the export. It was like an export.
Just tell me.
Okay, so there's a special handling for the maybe, right? In the export syntax.
Yes.
The export has a special handling for maybe.
Yes. Now it.
I was just wondering. So this export the make a test Java, and it exports the Java syntax or maybe it's either export or not. I wonder if there's special handling for other standard Haskell types like either.
No.
Like either.
By the way, now it's easy to see that because.
You showed us, right? There was just
yeah.
It was just maybe and bool.
Maybe bool and otherwise, nothing else. And seems that there is nothing.
Because boolean, it's not a type construct. Boolean, it's right. Maybe it has a type parameter. Boolean doesn't. It's interesting that this is on the same level.
Okay, I don't say I did this correctly. Yeah.
No. You fixed it. So.
Yeah, this is like fixes the problem, and I even commented that I have some solution that works, but I would need a guidance. But they are at the moment thinking about accepting it, like good enough for a moment.
There's like maybe special handling of Boolean as well. And this is foreign export.
Okay, I don't know why do they do this with Boolean. It's for me actually very interesting. I have, especially that you see that what they do here is like they take 1. This is like a constant. They take 1 and then they subtract it. Why? I have really no clue why this is done this crazy way. So, get tagged method empty. I don't know. So I don't really see a special why Boolean is done in a special way, but maybe for performance reasons, I don't know. This would be also interesting to check what happens if it's not there. Okay. I think this is integer subtract, so it means we okay. And let's do the best thing. Let's check it in a code ei sub. It's there, int subtract. So it takes 2 values from and then it subtracts. Yeah. So now the point what was iconst, but that actually should be easy. Iconst is load the. Okay, no, that's interesting because I think we had iconst. Oh, this was not this iconst. Now the problem. Because we are already on one level of iDirection, if we look for this iconst, this is not directly because there is no opcode called iconst. There is opcode. There are those but there is a method here. No, this is wrong. Sorry, just not this one. Which that should be in code HS, but I don't see it. Okay, icon space. Not this, not this. Oh, this icons is actually used more. Oh, but this should be here in code HS. Yeah, this is this. So icons is a special method for field type, now in some integer, and then returns a code. Yeah, so it's, let's say, more generic than the original one. So it's just a wrapper to make it easier. Yeah, but nevertheless, so I would say in this particular case it seems crazy because they could actually as well use directly iconst1, but I don't know. Yeah, because this is for 1. Then they subtract. This is a good question. So we load 1 on the stack, then we do subtract. We are subtracting 1 from something that was a result. Okay, but really, I don't really know why they do it this way. Maybe there's something. There's a question how bytecode actually works with booleans. Maybe this is just integer, and that's the point. Okay, so I think this is the problem because now this is a load a byte or boolean. Doesn't really. Okay, I cannot tell why this code is there. I would expect if it was because a boolean is a byte. So in that particular case, it makes no sense. Okay, but if you want, we can create experiment and do a foreign function that returns boolean and check what happens. But it will take 20 minutes to check it. Okay, but nevertheless, I want you to. Sorry, what? JCI, but yeah, that's the problem. Someone also suggested that it might work. I don't believe. I can try. I have never tried to work with ETA from GHCI, but I don't think it could. Nevertheless, a few things about this ETA structure. So you've seen codec JVM, which basically describe like all bytecodes. Here we have a compiler. Actually, most of the time something wrong happen is in CodeGen. What is a CodeGen? Let me show you. So you've seen a foreign function declaration, but actually the real meat happens in a different place. This is just this was not really typical case. Moment. Oh, maybe layout HS. Just a moment. I will show you layout HS. Yeah, CodeGen. Oh, not this one. So most of the time, actually, code you've seen something like code, and this is basically just a list of bytecodes that we just generate, put and put. But actually, there is a monad, special monad called CodeGen, which describes the state of the generating of a class. Because if we have a method in Java, I can show you that. You see, especially here, that, oh my God, it's too much code I have right now in memory. Oh, I'm swapping. I'm swapping. Okay, that's crazy. I have to remove. Okay, so the structure of a class file is very complex. It has a lot of like references, pools for constants, pools for something, and it all has to be calculated. If you just add one bytecode, it means a lot of other things should be like that reference the method, and if you add like one string or something, a lot of things has to be recalculated. And basically for that there is a special monad created, CodeGen. It basically means in this moment I generated so much code and I am able right now add a method to that, add some bytecode, add some const, and it is responsible for keeping it let's say consistent. So, and this layout HS is actually a very interesting place where you see things like, I can even tell you, this is for instance responsible for, just a moment, this is I think responsible for tail call optimization. This is exactly place where we do graph analysis after we change it to while loop, which variable will be assigned to which variable. There was a bug there I was doing. So this is an interesting place. So if you actually are generating, you are fixing something in a bytecode, so you have to add something in a bytecode, more often you are actually here in this package code gen than in this other part of with layout. So okay, and as well here we have from time to time, and we have closure Java. So we have definition of this closure, and this is Java runtime. So not only we have Haskell code, but we have Java runtime, and sometimes the changes are done here. So we can optimize something. There were already a couple of interesting stuff. So if someone knows Java, this is also an interesting place to work with. Yeah, so, but yeah. What is really important that most of the structure of this compiler is really the same as in GHC. So even the names are, there is somewhere thing called the base. Where is the base? Okay, I've lost it. Eta, moment, float, actually, float, HS. So this is the core libraries of runtime system, actually, and library called base. So you, for instance, have a definition of float, where exactly, this is almost exactly as the same thing in original Eta with this small moment where foreign function interface. Foreign, oh, it's not, oh, I read, no, yeah, sorry, this is, again, I'm swapping. I have too many things open and I wasn't prepared for that. Okay. Foreign. I think it's, oh, so foreign import, and you already see, you can even compare it with, this is like float is a non, and these are standard JVM classes. So I already showed that. So basically, so the typical errors are either in Java, or maybe right now there is one problem maybe with performance that I think can be fixed in this Java part, but maybe in compiler. And a year ago there were real bugs. Right now, if you look at the issues of Eta, let's see that actually, even though I'm not lying, but I think they are mostly having, let's say, extensions like enhancement can work around, performance can work around, and performance, blah, blah, blah. Is something marked as a bug? Oh, yeah, someone, so there was a bug, like, but they don't have like big problems right now. Yeah? I don't, maybe it's, I don't even know it. Okay, I know about one very painful bug at the moment, and I'm thinking about doing it as a next step. So you can have a very large Haskell file. And everything in this file will be by default assigned to one class. Okay, you've seen that it's actually decomposed in many classes, but the basic definition will be in one class. The problem is bytecode and class definitions was created really long time ago. And it fails now because classes are limited in size. I've forgotten how big the size of classes is, but basically there are some crazy, I think there is an exact package for Unicode where they have definition of all crazy Unicodes, like, you know, 10 or 20,000 of Unicodes, and you cannot compile it with Eta because it generates too long class file. Very simple thing. And how to deal with that? There is like proposed solution is to encode gen to keep track how long thing you create, and in case it becomes too long, create like additional class like class Unicode 1, Unicode 2, blah blah blah, and split those methods. But it's not totally easy, but it's doable. Like, so there are such issues, but this is an extreme case. I would say, in my opinion, this is a crazy thing that still after 20 years in Java, we have so stupid limitations in the size of a bytecode. By the way, in a lot of Java projects where, for instance, code is generated from like for XML parsing or for something, exactly there is the same problem. You cannot generate because it's too big for class. Yeah, so actually, Eta suffers the same as Java. Oh, someone had the same other bug. So there are some bugs, but this is not that often. So it's cool. Okay, let's slowly go Yeah. Because I wanna, this is a 5, and how much time do we have more? Okay, I don't wanna use full hour just to use it, so I'd rather answer your questions. So cool stuff is this Java P that helps you. Dumping STG. Oh, one. Dumping CG trace. So that's actually very useful, and you've seen that. So you can have something like this. So there is no, I don't know, easy way to debug this code generation, why it's happening, to debug a compiler really in a step by step. Maybe there is a way, but I'm not good at the moment to find out, and no one told me how to do that. I already asked. But you can do classic debugging by putting something to output while you do that. And not everywhere, because this is I/O operation. So you, for instance, you cannot do that in places where, like, let's go to the S4A. How it's called? 4A? Okay, different way. I will. I'm okay, sorry. I was thinking about this. So if you have DS4A, which returns here a code, you cannot do much, because you cannot, what you can do is do a panic error or something and you stop. But if you are inside of CodeGen, you have a special way. Moment, CG trace, do I find something like this? Or better, PPR, not here, okay. Just a moment, because most of the debugs are right now removed, but I'm sure some of them are there. PPR. Or trace. Debug trace message. Okay, for instance, you have this, but oh, this is better. Okay, so you can basically, oh, there is a trace in line. Okay, sorry for that. I wanted to show the simple trace, PPR trace. Okay, like, for instance, this. So you have just a special case. You do a code. I don't know what it exactly does. In this I have never been in this place of code. But then if you have a problem, you can always do this PPR trace and, for instance, say that in this moment, PPR is basically, you know, show in Haskell. Who knows show in Haskell? Show basically takes your type and presents it as a string, as long as you tell how to do that. PPR, it presents like, let's say, pretty printable trace. It's from pretty print. And you have special methods to basically additionally generate this. And that's, by the way, this is, I actually do mostly this kind of debugging if I'm really in the code gen. So that's how I can find out what is happening and basically print everything. And in ETA, almost all important compiler structures like type, like field type, everything is pretty printable to this CG trace, so it's cool. Even bytecode is pretty printable, so you can basically print everything what you need. Okay, so let's continue. So what is the problem? I think right now the good, what I can do for ETA is to describe all these definitions, because there was in the past small page describing what you see. It was like in the old code, it was removed, but I think more people want to know how to fix stuff, because it's really easy, but they don't know tooling. And maybe there is a better even tooling that I'm using, but we don't share it. So I think ETA needs some kind of documentation for exactly for contributors. So interesting places. Okay, I already showed all those things. User Gitter. Okay, I can tell you that. I can show you that. This is actually what I love about ETA. So some people use Slack, but I think this is mostly all mostly fast. So let's say that was exactly, for instance, May 26. I asked about this compiler debug because I forgotten. I basically had a problem with computer. I have to move to another, and some of my documentation links I couldn't find out anymore. So I asked for this, and the guy, Javier, sent me that. You see, it's typically 1 hour late, even not 1 hour later, I got an answer. So they really quickly answer to the questions on the GitHub. That's cool. So you don't have to be contributor, you don't have to provide anything, just they answer to the normal users. So, and this is actually, I would say, one of the best things with ETA, that you basically ask something and you really, those people want you to play with that. So it's visible. Then they are building, and you see the answer basically to everybody. Okay. Okay, although I have stated something, but maybe I have to repeat it. No one answered to that, because recently I've seen some memory leak, but I will post it probably as I haven't yet isolated it. Okay, so let's go a few steps back. Current state of ETA. So I wanted to show you that. You see from the issues, they have a lot of them, but mostly those are not like critical bugs. And like even this nulling, this was not a bug, and the question is if it's really a good solution, but okay. Tooling is growing, so I cannot tell you a lot of things because I simply, I'm not using everything ETA has. I mostly, you know what, I will close the ETA, because this actually, you see, I think that was 6 gigabytes in memory to yes. For ETA now it should work better. So what we have about ETA, and so we have, this is very important. Gradle ETA was for Java developers, so that let them easily use ETA. ETLAS, of course, was for, and ETA package was for Haskell developers. SBT ETA is for Scala developers, and as well works. I'm missing something. Okay, they are thinking about plugin, but I think no one is doing that right now. FFI, and this project seems to be dead actually. But okay, moment. I think that's what that was. But I don't know. So they work on some better tooling, and they have a lot of plans. The question is who will do that, all that stuff. And that's a good point. So I see. This is they've created some libraries with mapping for common, let's say, common Java classes. Okay, that were somehow not already done. ETA FFI was a project, but right now I see it's that I was actually, okay, this was this, subscribe. They wanted to create a tool that basically automatically generates imports, so you don't have to repeat them, but I think it's not ready. Okay, nevertheless. So I thought it was working for me some time ago as at least with something simple, but I wouldn't now expect it works. Okay, but okay. Nevertheless, to fix that, some of those tools, especially, come on, generating imports from Java, you analyze. This should be easy. Basically, I think no one needed it so much right now. Yeah. So, but this is a thing, for instance, one of you can do. Now, maybe to the point, if you want to use it on production, that's the only way to discuss with TypeLead. But I fear this question. I never heard about any answer and any contract, but I don't know. Maybe someone has it. I have absolutely no clue. The really good thing, you might, of course, if you are into Haskell, the GHC, of course, is a thing of choice, and yeah, why not use that? But the cool thing, really, from time to time, maybe you would like to use like audio library, like graphic, I don't know. I hope you don't have to use like which happens to deploy your stuff on a WebSphere, in which case as well you can deploy it with ETA, that's not a problem. But hopefully you don't have to touch it. This is really bad thing from the past. It's even worse than Balrog, but nevertheless. Okay, so for fun it's now good, and especially if you want to play with Haskell, that's how I found how can I do something sensible that at least someone will maybe benefit from that. Yeah, you can even make mistakes, like someone will correct them, so don't worry. Okay, yeah, that's exactly my point. And for me, it worked. I would say I learned. I'm not a good, still not good Haskell developer. I do like, you know, this, I dig into ETA once a year, mostly before a bigger workshop. Or last year, when it's really not that often, but for me, it's like I wanted to do this workshop to be back in ETA and do something and have time for that and be a little bit forced to do that. I already meet people on conferences that used ETA for this and this. Never heard about anyone using it for a critical thing, but already like for some, let's say, how to say, for business, it means that it was used somewhere. Maybe for a small thing, but it was used. So it's working, and people are working on tooling. I do recommend it, especially as a place where you can just jump into open source community and do something really cool. Compilers are cool. At the end, this, for instance, this code of, I can tell you, this code of generating telco call optimizations, I can tell you, it is actually taken from original GHC, which has in other place the same issue, but it was really cool to write it. So much better than writing, you know, crazy stuff, you know, generate web page or whatever. Now you had to solve, find cycles in graph and stuff like this. This is how you play with compilers. This is cool programming. Yeah? Okay, so that's, I think, what I wanted to show, I've shown. If you have questions, I'm still open. Okay, so thanks, and see you later during the conference.
Is the Scala any different than Java? Do you expect it to be better, richer?
No. So there are actually more people, in my opinion, work with Scala ETA together than with Java and ETA, but I cannot tell you because I haven't seen any, like, say, specific issues. Maybe this is, like, I've seen that recently someone complained about SBT plugin, but I think this is mostly about SBT, you know, writing something with SBT is hard.
I'm not asking really how well it behaves, more like, you know, can you do more work?
No, okay, there is nothing I'm sure about it. Let's say I'm sure, like 99%, there is nothing in this in exports or imports that is specific to Scala that you wouldn't use in Java. This is, by the way, the imports and exports instructions are very simple. There is none. No, and this is for Java. Yeah. So the point is actually even more than sometimes to work with. Actually, in Scala, you have to, the same as in Java, like if you work with Scala with Java, you have to write some wrappers. So actually, it's even, I would say, at the moment worse. I expect so. But maybe they did something, I don't know. But I wasn't checking.
Even at the moment work only with JC 7.10?
That's the good issue. So they
I noticed because I was trying to play install it and was JC.
Okay. That's a very good issue. So they forked ETA. Oh, I can tell you about something else. So what's a problem for ETA in the future? They forked in the moment there was JHC 7 some time ago. And they were already working on JHC 8, which brings some changes internally. Now we can generate LLVM code and stuff like that, some compiler extensions. So and they realized, oh, this will be now hard. We have to redo our work. This would be a bigger project to be back with again on JHC 8. That's a typical problem when you do a fork. But what they did already, I don't know the names, but I already know that they've backported some extensions, some features from JHC 8. But basically, they are still, let's say, JHC 7 core based, but they backported some features. They had some problem with at least one or two. I was just reading, but now interesting stuff. Oh, that's the point. I didn't have time to analyze it, but what is as well possible, but that will be like this is even more better than Eta is, let's say. This is Eta, I would say, works, but what I'm telling is like you have to really dig into crazy places. There is a Graal VM. I was telling you about the Graal, the compiler inside of Java virtual machine. But there is something basically done by similar teams in Oracle called Graal VM. And this is, I guess, have this compiler inside, but this is like separate virtual machine which is able to run other stuff than bytecode. For instance, it can run LLVM, which means with GHC8 you can generate LLVM and run this with Graal VM from Oracle. Even more, actually, but this is something I couldn't prepare, I just didn't have time. But I already was discussing with Oracle engineer, and it's doable, he promised me at least, that in this LLVM, I can actually call Java. It means it would be possible, I haven't, this would be like, I would need probably a couple of weeks to make it sensibly working, but it would be possible from GHC8 to call Java, generate LLVM, which would be running then on Graal VM, which will be normally calling Java. And I expect that might be actually like a killer thing. Actually, unfortunately, it might be even killer for Eta, I don't know. We'll see. At the moment, I would say it's not because still it's a lot of work to be done and still, okay, I think they need more tooling. And so Eta is, let's say, closer to the thing being usable. One thing I've forgotten to tell you, ahead of time compilation. With this Graal, with new JDK like 11, 12, you can compile ahead of time Java code. So you basically, there is kind of a linker in Java, special that you call, you say those are my jars, this is the main class, and it builds native code from that. It's basically like this. And if you, for instance, do command line things, this is a cool thing. So ahead of time Java compiler, this is really easy. But also instantly it's visible that the code made from them uses less heap, starts incredibly faster, almost, okay, not as fast as C code because Java runtime is still something, but it's like millisecond to half of second, like this thing. So it's really great. But in the long run, this code is obviously slower because it's statically compiled, so Java compiler doesn't know statistics, doesn't know which part is chosen, how often, so generate guesses, and guesses are often wrong. But it's already there, so it's really funny. It took 20 years for Java to create this tool, which is, by the way, obvious. It should have been created, yeah. But they also finally they did it, so it is.
It's like F6 in F#.
Mm-hmm. I don't know what's your question or this.
No, I'm saying it's similar to the F6 run, like the scripting extension for F#.
Okay, I don't know simply that. Sorry, like I haven't used it. I'm not into .NET, but okay. Yeah. So, other questions?
I thought you mentioned that the self-hosted compiler optimizer didn't give you improvements with Eta really the way it did with other languages. Did I say that right?
So sorry.
I think you said it was Graal VM, but essentially that it's a self-hosted, it's a compiler / optimizer written in Java, and then it didn't have big performance benefits for Eta, but it did for.
Yes.
And I'm wondering, because you said that it was better at blackballing unused code, I'm wondering if it's just the lazy evaluation means that code never got run in the first place with Eta. So it's sort of.
Okay, I don't.
Just as a thought, it's like we sort of already have our own blackballing just through lazy evaluation.
I would say that I expect that this Graal is better for other languages, like for Scala, because it exactly the engineers from that are given, like they are working of pieces of code from Scala where they exactly try to make it faster and check what is well. I don't think, for instance, Eta at the moment is their goal, but maybe one day they will look at the Eta and they will check what can we do simply to make ETA faster, and maybe there is a very simple thing to be done. I don't know, but this actually fixing something in JVM is like level harder than doing that stuff in ETA. So it's like even with Scala, maybe okay. I have to try. I never tried it so far. I tried with old JVM, with really so-so results, but with C1. Okay, I just had something that, okay, I forgot. So, yeah. Any questions? Are you going to use ETA on production tomorrow? Everybody? So next Monday, okay, it's cool enough. No, I would say I am working for, let's say, stable companies, unfortunately in Switzerland, that like some of them are like older than 150 years, really, more than 90. You know, we have really legacy code, that's really. And I see a lot of problems. I couldn't promise, for instance, that if I bring ETA, everything will be fine. Yeah, that's my problem. But on the other hand, I do say, being pure, having the language, having this sophisticated code, this brings the additional level of safety that I need. I don't have it in Scala. Scala, it's like I love Scala, but if for instance, I've seen it once, where is the benefit if you don't know that? In Scala, in any place you can do any imperative crazy thing. So you can have functional code from outside, but internally everyone can do statement like, I have a function that it's supposed to be pure because it's like used 10,000 times in an event handler, which basically has to behave consistently. But if someone, for instance, does check inside of that, what's the date, current date? That is the typical mistake of juniors, let's say, or even architects in like old architects writing event-based system, that I check for current date, which next time system is interpreting event, it's the different date. So in Scala, you have no easy way to prevent that. You have to just review the code. In Haskell, you basically, if it's not inside IO monad, you cannot check for date. So compiler prevents you from this kind of bug, which is cool. In Scala, you always can return null. Still not so. By the way, they solved it in Kotlin, which is so cool. Finally, someone solved pragmatic way null problem. Yeah. You can throw exception anytime. It's everywhere. Yeah, so there is a lot of, and this is not as bad. I would say the biggest problem in Scala is basically because of this. Okay, this is not a real problem, but it's somehow that makes it a little bit dirty. Like this should be solved by the compiler, not people checking line by line. So that's why I wish this kind of solutions would be more popular, but especially, for instance, for critical parts of code. I want this part to be like proven, self-proving that it's cool.
Well, there's another question actually I forgot to ask. In the Java Haskell API, exceptions, how are they mapped? Is there a story there?
I don't think they are mapped at all. That's a good thing. Shall we?
So if Java throws exception, Haskell just crashes, or if Haskell throws exception?
Okay.
I/O.
Moment. We can do something about it. This is a good question. Never tried it. We have code for that. So if we go to exercise 2, Java code. But okay, we don't. Do we have? Okay, we cannot throw. This is not the best case because we don't have Java class that it's called from. Do we have somewhere the Java code that is called from Haskell?
The get color.
What?
Get color.
Yeah, but that was okay.
This is Java implementation.
This is Java implementation, yeah. I would have, okay, I have this, but it's easy. Because I had it actually here in this null. So why? Sorry?
And then back to Java.
Well, back to Java.
It's Java.
difficult to actually throw, to use some I am one error in Haskell and see what Java.
Okay, I just see I don't have anything ready for that. Shall I write something like, I would rather, I just have no idea how to make it, how to make sensible call. Okay, you know what? Let's leave it. I haven't seen anything about exceptions, but there is like, you go to Eta-lang, let's see, documentation, user guides, and there's like the Java interop here. And the question is, do they even mention anything about exception? I don't think so.
So you should not even talk about it.
Maybe it's not the question is
Okay, I would say if you, what I expect, but I cannot tell you, if you throw exception in Java that it's called, then probably there will be like panic in Haskell. What else can there be? And vice versa, if you panic in Haskell, then probably there is like exception in Java. That's sure.
I think that's the unsafe, right? Like you're saying that, like you're assuming that it's just not going to fail.
Yeah, yeah. There is actually this thing as well here. But where you've seen.
You can handle exception in IM1. So probably this is the story. You handle them in IM1.
Okay, that would.
How are they communicating?
So that would be like 10 minutes to prepare the good case for that. But well, sorry for if you wish, I can try right now. But I'm already tired. Okay. The next thing you might think about it, like have a special encoding for either, where you handle exceptions. Why not? Is it the proper way? I don't know.
Yeah, that would be interesting, right? If you can declarative specify either in the foreign export, and then magically exception in Java
Are left, yeah. Yeah. But you know, the point is, I can now tell you, I'm mostly writing Kotlin code and a little bit of Java. We stopped using exception some time ago. So basically, I'm using either in Java, mostly. I know there is a like old code which doesn't, but we are slowly eliminating it from Java as well.
Right. But there's always a risk of null pointer, right? Because you haven't followed something already.
You can have null pointer. Okay, as you can have always bottom in Haskell, yeah.
The same thing is true in Haskell.
Yeah, I think it's true in regular JC as well. If you're doing unsafe imports, like you have an expectation that this is really good code. It's battle tested. It's not gonna.
Yeah, but so I think this question about exception, but we would have to create a few cases like exception from Java, exception of panic from Haskell. I won't use this 10 minutes. I'm really tired, but it's interesting. You can post this as an issue, and maybe I will have time to analyze. But I need a sleep.
It's probably simple dash.
Yeah.